In this video, we're asked to prove the common segment theorem. Given PR is congruent to QS, we're going to prove that PQ is congruent to RS. So visually, they want us to take the segment here, congruent to that segment there, and recognize that QR is in both segments. So if we were to take that QR and remove it from both parts, we'd end up with PQ and RS, two new segments, which would be congruent to one another. In order to do this, we're going to have to use the addition property and segment addition postulate. We'll start off with PR congruent to QS. If I use the segment addition postulate, I get PQ plus QR equal to PR, and QR plus RS is equal to QS. That's your segment addition postulate. Once I know that, I've given myself PR is congruent to QS. So these two things are equal to one another. So let's take PQ plus QR, which is one way of saying PR, one way of saying that right there, is equal to QR plus RS, which is another way of saying QS. So step 1 and step 3 pretty much say the exact same thing, except for I've rewritten PR as the sum of its two parts, and I've rewritten QS as the sum of its two parts. And that's just substitution. I rewrote the first, I substituted PQ plus QR for that, and I substituted QR plus RS for that. Now I recognize that, with a statement like this, whenever we have two things on the left-hand side and two things on the right-hand side, we want to see what we can remove from both sides. And in this instance, we've got a symbol over here, QR, and a symbol over here, QR. They're identical, and their symbols, they represent values. So I want to take QR, set it equal to QR. It's the reflexive property. And the reason I do that is so I can remove it from the left-hand side and remove it from the right-hand side. And that's going to leave me with PQ equal to RS. Actually removing this from the left-hand side and this from the right-hand side, that's subtraction. And then step 6, I can say PQ is congruent to RS. From step 5, if I know their measurements are equal, then their shapes are congruent. And that going from equality to congruency is the definition of congruency. And we've proven now what we were asked to do. At the onset of this, I said we're going to use the segment addition postulate and the addition property of equality. And as stated, all we had to use was the segment addition postulate.